Hey guys, yesterday we talked about solving quadratic inequalities by graphing. Today we're going to talk about solving quadratic inequalities algebraically. So if you could flip to section C in your 4-8 notes from yesterday, and then we can get started. So I'm going to walk you through a problem that I've already worked out, and then I'm going to ask you to do the second example on your own. And then I'll come back and go through that example so that you can check your work. Okay, so this first example, it's asking us to solve x squared plus 11x plus 30 is greater than or equal to 0 algebraically. So step one, we want to solve the related quadratic equation. So we're going to switch that inequality symbol into an equal sign and solve for x. So far we've talked about factoring, completing the square, quadratic formula, square root property. We're going to use one of these to solve the quadratic equation. In this case, this is nice and factorable, so it's going to factor into x plus 5 and x plus 6. And then once we set both of those factors equal to 0, we can find the value of x. So in this case, we have x equals -5 and x equals -6. Now keep in mind that it's not always going to be that nice when it comes to solving for x, but I just wanted to pick a simpler example so that you can see what's going on. So after we have solved the related quadratic equation, we're going to plot the roots on a number line. Remember to use dots or circles depending on your original inequality. So if we go back up here, we can see that equation is greater than or equal to, so we know that our dots on the number line are going to be closed because we are including the solutions. Okay, after we graph, or after we plot these roots on the number line, step 3 is we are going to test a value in each interval to see if it satisfies the original inequality. So in the interval when x is less than or equal to -6, I chose x equals -8. So we are going to plug in a value from each interval into the original inequality. So if we go back up here, I'm plugging in -8 into our original. So we see that after we plug in -8, it comes out to be true. So 6 is greater than 0. So we're just going to put a check mark for now. Next, we want to test the middle inequality. So we're going to test a value between -6 and -5. In this case, I chose x equals -5.5. If we plug that into the original equation, or the original inequality, we find that 1/4 is not greater than 0. So I just notate that with an x. Third, we want to test a value when x is greater than -5. So we're testing each value, or one value from each interval on that timeline. So I chose x equals 0. When we plug in x equals 0, we find that 30 is greater than or equal to 0, and that is true. So now I have my solutions. So I have solution x is less than or equal to -6, or x is greater than or equal to -5. Okay, so we went through those 3 steps. Step 1, solving for x, finding the values of x. Step 2, we plotted those on a number line. Step 3, test one value from each interval and see if that satisfies our original inequality.